Okay. Class example 3 states, no phones out, no talking, just watching so you're not lost. In April 1986, the nuclear accident at Chernobyl contained the atmosphere with quantities of radioactive iodine-131. Now, we see beside iodine-131, that's not how much iodine is there. That has nothing to do with the question. It's just the isotope. So that 131, completely useless. Okay? So cross out the 131 if it says phosphorus, whatever, iodine 131. I always go beside and do this. Oh, good. So, gone. It's great that it tells you that. It has to tell you that because that's the type of iodine it is. But I always cross it out so I don't try and put 131 somewhere, which people try and do. This is where I would bring out my highlighter if I had a highlighter. Okay. And I do, so I'm going to. So, it says in 1986. 1986 is important in the fact that if it asks me how many years later, you could tell me what year later or whatever if it does that. So it says if the half-life, so it has the word half-life in it. If it has the word half-life, doubling, or tripling time in it, we turn to that formula. It has a half-life of 8.1 days. So you tell me, is the 8.1 T or P? It's the 8.1 T or P. It follows after the word half-life, so it's P. It says it has a half-life of 8.1 days. P represents the period of how long it takes to half or double or triple. So it says it has a half-life of 8.1 days. That means its period is 8.1 days. Every 8.1 days, this isotope is halving. This iodine is halving. Okay? So we know that R is 0.5 or a half. You could use either one. They mean the same thing. R is a half because it's halving, or 0.5 if you want to use a decimal. We know P is 8.1 days. We know, therefore, that T has to be in days as well because P and T have to be in the same unit. So what else does it give us? Determine the number of days to the nearest day. So that's what we're finding out in the end. We're finding out the nearest, the number of days to the nearest day. So that's whole number. If it was one decimal place, it would be to the nearest tenth of a day or the nearest hundredth of a day. If it says nearest day, we go right to the whole number. It took for the level of radiation to reduce from 100 to 2. So we're reducing, which we should because it's half, 100 units to 2. So, what's my final? 100 or 2? 2, because it's going from 100 to 2. My final needs to be smaller, you guys. It's halving. If it's halving, that means it's going from something bigger to something smaller, right? So my final is going to be the smaller number. So my final is 2 units, and my initial is 100 units. So then we need the formula with the R. What are we looking for? What letter? T. They often make you look for T or P just because then they're making you find the exponent, which is we're an exponents unit. So T, we don't know. So let's fill in. The only way we can solve for this formula is if we're missing one thing. If we're missing more than one thing, go back, try again, because you can only be missing one thing to solve for, right? If we're solving for the variable. So we have final equals initial rate to the T over P, time over period. So the final is 2. The initial is 100. The rate is 0.5 or a half if you want. T we don't know, so I'm going to put an X. And P is 8.1. Now you're going to follow along so we fill this in correctly. The very first thing I always do in this instance is divide that A value, that 100 over. If you do that, your window is often easier to find. Okay? So I'm going to divide this I value over. Always. That's my very first step. So now I have 2 over 100 or 1 over 50. That's fine. If you get a decimal, you need to write the entire decimal. So turn it into a fraction, or you need to keep the whole decimal. You cannot round. If you round, you're going to get your answer rounded wrong. Okay? So you have to keep the whole thing. And it equals 0.5 x over 81. If we can't make common base, which in this case doesn't look like we can, if we can't make common base, we're just going to plug these into our calculator. And that's all you guys have to do. If you can't make common base, they'll allow you to punch them into your calculator. So we're going to put this into y1, the left side into y1, and the right side into y2. Keep in mind that if your calculator does not have the exponent pop up, you have to put the exponent in brackets. So in this case, the y2 is going to be 0.5 to the exponent x divided by 8.1. If your exponent pops up, you do not have to put it in brackets. If your exponent does not pop up, you have to do that. If it looks like that, it has to be in brackets. Okay? If you do not put your exponent in brackets, you will get it wrong every single time. So everyone type that into their calculator. In y1, you're going to have 1 over 50. And in y2, you're going to have that. Then what do we always look for? Where they intersect. So we're going to have 1 divided by 50 in y1 and 0.5 to the x divided by 8.1. And then I always start off with the standard window. Now, this is 1 divided by 50. It's really small, correct? But what if this was 2,000 over here? Then my y max would have to be at least 2,000, or I wouldn't see the horizontal line drawing at 2,000, right? You'll never see it. So you have to always make sure your y max is bigger than whatever this is. This is 1 over 50. It's a really small decimal. It's less than 1. But if this was like 2,000, my y max would have to be 2,000 at least, or I couldn't see that line, okay? So go zoom 6 and start off with a standard window. If you can't see where these cross, what happens? Error. It can't calculate where it crosses. Now it's really, really, really close to the x-axis, so you might not be able to see that 1 over 50, but it is there. So let's go second, trace 5, enter, enter, enter. Ooh, it says quit, no sign change. So that means that it's drawing a line like this. Right now in my window, it's drawing a line. My window's like this, I guess. It's drawing a line really, really close to the y-axis that you are barely being able to see. And then it's drawing a graph like this. And what's happening on my screen? I'm not seeing where they cross, right? So I need to make my x max bigger so that this keeps drawing, and eventually you'll see where they both cross. So I'm going to go to my window and I'm going to make my x max be 20. And then I'm going to try again. Second trace 5, enter, enter, enter. I don't need to change my y max. I don't need to change my y min. And I don't need to change my x min, because none of those are going to make me be able to see where it's crossing any better, right? Just my x max. Is 20 big enough? Or does it error you? It errors you. So I'm going to go to my window and make it be 40, my x max. Second, trace 5, wait for it to draw. Don't go enter, enter, enter super quickly, or you might end up erroring. Everyone should be trying this, because just because I can do it with my calculator doesn't mean you can. I'm not writing your test. And if you call me over and say, Mrs. Lepp, can you fix my calculator? I'm going to say no. It's your test. You need to learn how to run your calculator. I can't even be in on your diploma. Literally can't walk in the room. So you're going to have no one helping you. 40 doesn't work. Let's try bigger. 100. get 45.715235. Time, you have to always round up. So this says to the nearest day. So I would round it to 46. But you guys, even if it was 45.1 days, I would still round it to 46. Because if I rounded it down to 45, I wouldn't be 2. Like I need to be to the lowest. So let's think about it this way. I always like thinking about it this way with time. So if say I had $1,000 and I needed the money to double so that I could go buy a car. Okay? So I had $1,000. But I needed to get to $2,000 till I could buy the car. Okay? Let's say that it takes 4.1 years. Let's say to get to 2,000. All right? It takes 4.1 years. You need a really good interest rate even for that to happen, by the way. So say it takes 4.1 years. Could you walk into the dealership at 4 years and buy that car? Probably sold at this point because that's 4 years and they're like, no, thank you, sold that. But at 4 years, could you walk in and buy the car for 2,000? It takes 4.1 years to get to 2,000. So could you go in at 4 years and be like, hey, I have about $1,800. Will you accept that? They'd be like, no, come back at 5 years when you have at least 2,000. Would you have more money than you needed? Yes. Would they send you away because you have more money? No, they'd send you away if you didn't have enough. So time, we always round up. Okay? So in this case, it would be 46 what? 46 days. Whatever the one is in, the other has to be in. So whatever P is in, T has to be in, same units. Whatever T is in, P has to be in the same units. Okay? I want you guys to try class example 4. Trust me, it helps if you highlight the important information. So I'm going to get you guys to try and fill it in. Use pencil because you might pick wrong. Okay, you might fill it in wrong. Remember, you can only be missing one variable, and that will be your x if you're solving. All right, so try that one out. A patient feeling ill has a sample of bacteria taken from her throat. The sample contained 387 cells. So that's initial, right? Initially, that's how much they took. So 387 cells. 24 hours later, the sample contained 8,012 cells. So is that time to reach final amount? Or was that the time, how long it took to double, triple, half, whatever? Time to reach final amount. Because nowhere near that time does it say that it halves that fast, or doubles that fast, or triples that fast. That's how you know if it's P. If it says it triples every 10 or doubles every blah, that's the P, right? It doesn't tell you that. It took you 24 hours, so that's T, to reach 8,012 cells. They want you to find the doubling time. Doubling time means R is 2 of the bacteria to the nearest tenth of an hour, so X. So what's the very first thing we do? We divide by that I value, right? So we're going to divide by 387. Now punch that into your calculator. If you haven't, make sure you have. So punch it into your calculator. Like I told you, if this turns out to be a crazy decimal, 8,012 and 387, you guys, you can just type it in as 8,012 divided by 387, the whole thing right into your Y1. Do not put a rounded decimal in there. That's bad. All right, so in Y2, you're going to fill in the other one. 2 to the exponent, 24 divided by x. Now, what happens, what do you suppose if you mix those up and put 24 in the P place and X in the T place? What do you think would happen on your test? It'd be wrong. And what do you else think would be happening? The answer is going to be there. You need to know which one goes where, because if you're 50-50 guessing and then just going to check and see which answer's there, both of them will be there. They will be, because that's the top answer that's going to be picked. Okay? both of those are going to be your top answers. So you guys, when we make diploma style questions, you need to have 3 distractors and 1 good one. Okay, obviously you need to have 1 correct answer and 3 distractors. It's really hard to come up with 2 really good distractors to this, because the good distractors are 1, having those flipped. Other than that, they're kind of like we're searching. The only other distractor I could think of is, hey, if you have a TI-83 calculator and you don't put these in brackets. Okay, that would be another distractor. And then the 4th distractor I would find really hard to make. If they can't come up with 3 good distractors that you're going to pick, the question is out. That's why this question is a numeric response style question. This one lends itself hugely to numeric response because it's very hard for me to find a 3rd distractor. If they can't, they'll make it a numeric response. Understand? All right. So when you type those in, second trace 5, don't just start going enter, enter, enter. You need to wait for them to be drawn. If you don't wait for them to be drawn and you like enter, enter, enter too fast, sometimes you actually like make it get like stuck and it's like, oh, I can't do it. So also sometimes you think, hey, I can't tell where they cross, so it's obviously not a big enough window and you make the window bigger. Just go second trace 5, enter, enter, enter on your 1010 window and see if you get an answer. Most of the time you can and you can't see it crossing. Only make your window substantially larger if you can't see it. Now also, substantially larger means, hey, let's make the 10 and maybe I'll make it be 30. It doesn't mean, hey, I'm going to go from 10 to 5 bajillion, which is what you guys do. You're like, okay, 10 doesn't work. Okay, 20 doesn't work. Okay, then 400 million. That will work. No, bad news. Like, don't like jump so substantially. I see that all the time, and then people are like, my window doesn't work because you made your window like, I don't know, 3 million from 10. Okay. All right. So it's 5.4. So you're going to put 5.5 what? Hours. All right. So I'm going to get you to work on a couple questions, and we're going to come back and do a different style of word problem. So on your pages, flip ahead. We're going to do these ones, and then we're going to come back and start a different type. So you're going to go to page 307. I'm a liar. You're going to go to page 309 and circle number 7. Circle number 8, number 9, number 10, 11, and 12. 7, 8, 9, 10, 11, and 12. All right, you're going to have, I don't know, probably 15 to 20. It might be shortened if I don't see you working. So you're doing 7 to 12.